Okay, students, good morning. Good morning, everybody. Welcome, welcome, welcome. I see that we are 12 students in the class. We're missing a couple of us. We're still missing a couple of students. I'm just going to put here my charger so I can put the computer to get some battery, okay? There we go. Okay, very good. Nice. Okay, students, so we're going to quickly start. Welcome. I'm going to take lists to the students that are here in the class. So let me take lists really fast. I'm going to take list, okay? So I see Eduardo there, very good. Let me get my pen. Okay, there's Eduardo. I don't have my pen. Okay, here, Eduardo. I also see Luis Pablo, Santiago, Silvana. Where's Julie, Juliet, Amsi, Elena, Leah Lagarde is not here. Okay, then I have Bruno, very good. Maria Angel, nice. Where's Maria Angel? Maria Angel there. Elisa is not here. Okay, Alondra is here, very good. Jimenez not here. Marco is not there, it's Marco. Leah, Nicole is not here. Pablo, Pablo Andre, where are you? There he is. And Libra is not here. Okay, students, very good. Nice. Okay, we're going to quickly start with today's class. Today's class is going to be about science. So welcome, first of all, to this class. And the plan of the day is going to be the following. We're going to go through lesson number 4 in model number 4. We're going to understand the vocabulary words. After we understand the vocabulary words, we are going to see the video in YouTube about the heat. Then when we finish seeing the video, we're going to read lesson number 4 and we are going to answer some questions, okay? The only material you will need is going to be your Pearson book. That's it. You don't need nothing else, only your Pearson book. And remember that we are going to finish, we're going to answer questions from 1 to 4 and questions from 5 to 8, you're going to answer them for homework, okay? Very good, students. So very, very good. That's great. I see you everybody here. So we're going to quickly start. I'm going to answer Alondra's question. Yes, Alondra, what's the question? Alondra.
Teacher, what do we have on homework?
You're going to answer questions 5, 6, 7, and 8 in your spelling lesson number 4, okay?
And we don't have homework of Spanish.
I don't know.
It's because I think that Miss Karina think that today is
English exams.
the exams. And I don't know.
Well, tomorrow that you are in class or right now that you are in your house, send an algebraics message to Miss Karina so she can tell you what's the homework, okay? Very good, Alondra. I'm going to put your hands down. Nice. And I'm going to see, Elisa, what's the question?
Teacher, 2 things.
Yes.
The first, I come late.
Huh?
I come late.
Yes.
And second, yes, we don't have homework of Spanish.
I know. That's what Alondra was telling me, that you do not have Spanish homework. And don't worry. Right now, I'm going to send a note or a message to Miss Karina to see what is going on, okay? Don't worry about that. And right now I'm going to send a message to Miss Karina to see about that, okay? So students, we're going to quickly start with our activity of today. We're going to quickly go ahead and work on the activity for today. I'm going to start sharing here the page of science. Okay, give me a second. I'm looking it in the computer. Okay, here it is. Okay, where is it? Where is it? Here, I found it. Very good. Okay, students, so we are going to start working on the science. Here is the page. So everybody go on your Pearson book to page 252. Everybody to page 252. And open your page 252, please. Okay, and we are going to start reading about this. We're going to read about heat. We're going to read what is heat, okay? You know that heat is what a temperature is very high or very hot. That is heat, okay? So everybody understand that heat, it's the energy that is produced by an element that it's under fire, or it's creating some energy, okay? In this kind of photo, different temperatures show us or show up as different colors. Okay, these are called thermal energy pictures. They show us the energy of the persons, or they show us the temperature of the persons, if they're hot, if they're cold. And every time these images are taken, they see our blood. Our blood is the one that has the temperature. It's not our body, it's our blood. Our blood can be hot, our blood can be cold, and depending on the temperature of our blood, that is how the picture is going to be, okay? So we're going to quickly start reading the vocabularies. It says, the question of the week, it says, I will know that heat flows from hot objects to cold objects. I will know that some materials are good conductors of heat and others are not. Okay, the words to know are conduction, convection, and radiation, okay? So we're going to start reading this, but before we read this, I'm going to quickly put you a video about heat, and I want for you to pay attention to this video because it's going to talk to us about what heat is, okay? So I'm going to put it here in big so you can see it. We're going to pay attention to this video. I hate sounds.
Welcome to What is Heat?
Okay, we're going to
Let's start with an illustration.
We're going to start with this quick video, and we're going to check all the information, okay? So pay attention to the video. You're going to learn a little bit about what is heat. So I want for you to put attention, stop doing whatever you're doing, and pay attention to the video, okay? The video is going to explain us what the topic of today is, okay?
Welcome to What is Heat? Let's start with an illustration. Here we have hot and cold blocks of some material, and they each have a thermometer in them to prove the point. If we put them together, what's going to happen to the temperature of the cold block and what's going to happen to the temperature of the hot block? Let's take a look. You can see that there has been a transfer of energy from the hot block to the cold block, resulting in the same temperature for each. Heat is a form of energy that flows from one object to another. What kind of energy? That's right, it's the flow of kinetic energy. And it is important to remember that the temperature is the average kinetic energy of a substance in contrast with heat, which is the flow of kinetic energy. So what direction does heat flow? You're right, always from hot to cold. This is a basic fundamental law of the universe. But how does that happen? What is happening at the particle level? And another interesting question to ponder is, will there still be any heat flow now once the two blocks have reached the same temperature? We will address that question a bit later. So to understand heat, we need to understand how particles are involved in the flow of kinetic energy. Let's back up a bit. Starting with hot and cold again, let's see what's happening between the hot and cold blocks. We'll take a closer look using a magic bus. As we zoom in, you can begin to see the particles that make up the two blocks. The kinetic energy is shown as vibrational motion. The lower block in red has greater vibrational motion. It has a higher average kinetic energy and therefore a higher temperature. The upper block in blue has less vibrational motion. It has a lower temperature. What happens when a slow-moving particle hits a fast-moving particle? There's a transfer of kinetic energy. And how does that affect their temperature? Yes, the cooler particle becomes warm, the hot particle becomes cool. Let's look again as we put the blocks together so the surface particles are in contact. The collisions constantly transfer kinetic energy, which is depicted here with the particles becoming purple and reaching a more intermediate rate of vibration, or in other words, reaching the same temperature. Note they need to transfer kinetic energy both between and within each block for this to happen. Let's get back to a previous important question. Is there any heat transfer now once they have reached the same temperature? Think about it. The atoms are still constantly colliding and so are constantly transferring kinetic energy, but there is no net change in temperature. The two blocks have reached an equilibrium once they reach the same temperature. The amount of heat going from upper block to lower is equal to the amount of heat going from the lower block to the upper block. The rate of kinetic energy transfer between the blocks is now equal, which defines the equilibrium. An important thing to mention is how the surface is being portrayed here, which is as a very smooth, unblemished surface. In reality, at the particle level, we would see an irregular surface with peaks and valleys, where only small localized contact between the two substances would occur and transfer kinetic energy. And yes, these particles are all vibrating. They have kinetic energy, but I will let you use your imagination for that. What is interesting about the gaps is that there are air molecules trapped in them, which we see here. The air molecules will act as an intermediary, colliding with and absorbing kinetic energy from the high kinetic energy hot particles, and then colliding with and transferring that kinetic energy to the slower cold particles and increasing their temperature. Eventually, the two blocks come to the same average kinetic energy, shown here as violet particles. So this video so far has demonstrated one of the three categories of heat, which we call heat conduction, the transfer of heat through the collisions of particles. There is also radiant heat and convection heat, which we will briefly touch on in the next two slides. Radiant heat is energy transfer through electromagnetic radiation, which is light. When photons are absorbed, their energy is transferred to the absorbing body, increasing the kinetic energy of its atoms. And of course, we can't miss this opportunity to show a partial dextro eclipse. Now on to convection, which is heat transfer in fluids. Convection describes the behavior of large aggregates of particles in a fluid, such as air or bodies of water, which does include kinetic energy transfer and other factors as well, depending on temperature differences between aggregates of fluid particles and other conditions within the fluid, all of which is beyond the scope of our video. This has been a Mad Scientist production. See ya.
Okay, students. So there, they showed us a little bit about, let me just stop sharing here. Okay, they just show us a little bit about convection, conduction.
Así que quieres aprender inglés.
And
Aquí tienes 3 mitos que son completamente falsos.
let me put this pause.
1, debes hablar mucho.
Okay. I just want for you to, I'm going to put it here. Okay, there. So students, there are 3 things very important that they showed us in the video. Conduction, convection, and also radiation or radiation, okay? Right now we're going to read a little bit deeper about what is conduction, what is convection, and what is radiation, okay? So students, before we start reading, I want to explain you this. What you saw in the video, it's most likely what is happening in the process of energy, okay? What is the process of energy? Is what is happening? There is something very, very, very special that happens here. Every time, students, that you have, for example, something that is very, very hot. Imagine that this coffee that I'm drinking right now is very hot, okay? What happens to the coffee is that the little cup here, this is going to turn hot. Why? Because the liquid inside of it, it's hot. So that's why they put these things to the coffee, to the teacups. They put this here so you can get it, because this part is separate from the teacup, and that won't allow the heat to get into your hand. That's conduction. That means that when you have something that is very, very heat, it automatically will transfer the heat to the object. Or for example, when you have a bottle of water and it's hot, you put ice inside of the bottle of water or inside of the glass of water, and the ice is going to melt. But that melting, it's going to create the temperature to go to a range where the ice is melting and the temperature is half. So that means that it's not going to be that hot, but it's not going to be cold. It's going to be neutral. The heat will not neutralize because of convection. Convection is when you neutralize the temperatures, when the temperatures come to the same level. Conduction is when one temperature passes through an object, okay? That's conduction, and convection is when the temperatures are equal. Right now we're going to read a little bit about this. Yes, Alondra, what's the question?
Teacher, how are we going to say when we're finishing here, can I read?
Yes, right now you're going to start reading. Okay, very good. Now, yeah, what's
Teacher,
yes.
wait. Yeah, ready. Wait, tomorrow we're gonna have exam?
Yeah, you're having a quiz.
Okay.
No, not tomorrow, on Friday. Tomorrow we're going to read the story. Okay, so I'm going to start sharing the science lesson here so we can start reading it. It says, conduction. Thermal energy flows from something warm to something cold. The transfer of thermal energy between matter of different temperatures is heat. A heat source is anything that gives off energy that particles of matter can take in. Okay, Alondra, can you start reading, please? I'm going to open your microphone. Okay, Alondra, please
Where,
read.
teacher?
When you go to bed,
Ah, okay. When you go to bed at night, does your pillow feel cool on your face? Is a pillow warm when you take up? That is a thermal energy moving. Your body is heat source. Thermal energy transfers from your body to your pillow. When solids touch, thermal energy moves by conduction. Conduction is a transfer of heat that occurs when one thing touches another.
okay, so what we're going to do, I want for you to, with a highlighter, highlight this, what it says. Conduction is the transfer of heat that occurs when one thing touches another, okay? Highlight that in your Pearson book. Highlight that because that's one of the definitions of conduction. It says, a bird warming its eggs is in the nest. It's another example of conduction. The bird's body is a heat source. Conduction transfers through thermal energy from the bird to the eggs, which are cooler. Okay, so what does the eagle in this case is doing? Okay, the eagle there is sitting on top of the eggs because the eggs are cold. So what does she do? She sits in the eggs and the eggs become warmer. Okay, so it says number one, visualize. Draw an ice cube sitting on a countertop of the hot day on a hot day. Draw an arrow showing which direction the thermal energy flows. Describes how the heat is transferred. Okay, I'm going to draw it here so you can see. Okay, imagine this is the sun. Okay, this is the sun. I'm going to put here the little sticks. Okay, that's the sun. Imagine that's the sun with a lot of imagination, okay? So that's the sun. And here in the bottom, I'm going to draw a cube. Imagine this little cube here, it's an ice cube, okay? Where do you think the energy it's going to come from? The energy, obviously, it's going to come from the sun all the way to the cube. And where is the cube? What's going to happen to the cube? Well, obviously, the cube is going to dissolve because the cube is water. But where is the water going to go? Depending, it's here and it's on top of a table. Imagine here is a table. Here is a table, here, here, here. That's a table, okay? Okay, that's a table. Where is the water going to go? Where do you think the water is going to go? To the front, to the back? Where is the sun coming from? The sun is hitting from the top to the bottom. Where do you think the water is going to go? The water is going to go this way. Oops. This way, or it's going to be going this way. Where do you think the water is going to go? Left or right? Who can tell me? Why? Nobody knows? It's a very easy one. Okay, Bruno, where do you think the water is going to go?
Right.
Where? Here or here?
No, the other,
Here? Why?
because the sun is hitting that part and the melting is going to start here and then it's going to happen this and the water is going to
Go to this side, right?
Yeah.
Very good, Bruno. That's a very good answer. Perfect, Bruno, very good. Why does that happen, students? That happens because the heating or the heating source, it's going to start from the top to the bottom because the sun is heating here. So yes, obviously the water is going to be here. It's not going to melt because this side does not see the sun. So practically, how Bruno says, the sun is going to start heating this side, and then it's going to melt this part, and then it's going to melt this part until the complete cube, it's melt, okay? This is going to be the last part to melt, okay? What I'm doing here, I'm just putting a little X here. That part that you see here, it's going to be the last part to melt, okay? Because the sun obviously first starts with this side, okay? It's a very easy, so you have to draw that in your book, okay? Draw that in your book so you can have it there. To that process, we say it's the conduction process and it's the heating source, okay? It's a conduction process. Because the cube is getting the energy from the sun, it's getting the heat from the sun, and it's turning into water, but it's gradually. What does it mean that it's gradually? It's not going to melt everything like that. It starts part by part, part by part. It's if you have here, see a cube in the sun, it does not create water like that. It happens gradually, paso a paso, step by step. First the top part, then the middle part, then the last part, okay? It's gradually, okay? So I'm going to raise this now. I'm going to raise it here, and we're going to go to the next page, okay? Let me go to the next page here. Okay, now I'm going to call people to read now again. Conduction examples. Okay, who wants to read? Bruno, I want for you to read. A conduction example.
Have you ever eaten a hot meal for breakfast? Suppose that you ate a bowl of hot oatmeal with a metal spoon. Why does the metal spoon begin to feel warmer? The particles of the spoon that touch the oatmeal start to move. As they move more quickly, they crash into other particles in the spoon. Soon, the thermal energy from the oatmeal moves throughout the spoon. Heat transfer continues until the oatmeal and the spoon are at the same temperature. Mister, can I say you something?
Yes.
Why sometimes they draw the sun with sunglasses?
Because it's very hot.
Mister, pero ¿cómo lo afectaría el mismo?
I don't know. Okay, so that's a nice reading, Bruno, very good. It's telling us an example of conduction. Here in the bottom, you see a picture of some oatmeal. What is oatmeal? Avena. When you create oatmeal in your cup, that's what I was telling you about the coffee. The oatmeal, it's going to create that the cup becomes warm because the oatmeal, it's hot. So obviously the coffee, the cup, it's going to be hot. So what happens here? When you put the spoon into the oatmeal, what is going to happen? The spoon is going to become hot. So when you do the blowing, that's how you're going to start making the oatmeal to get colder. And that process, it's an example of conduction. You're transmitting hot air, you're transmitting cold air to the spoon, and the spoon is creating the oatmeal cold, okay? It says number 2, how do you know that heat from the oatmeal has moved? Okay, have you ever seen the vapor that is going out of the coffee or about the oatmeal, or when you do a maruchan, always in the top, there's that little heat, that little vapor that is going off. It says, how do you know that heat from the oatmeal has moved? Okay, when you don't see anymore the little lights or the little vapor, what do you know? That the maruchan or the coffee, it's cold. So that's like an easy way to identify how the heat moves, okay? So what can we put here? When the waves of vapor, we're going to put, we can identify the movement of heat by seeing no more vapor waves in the cup of oatmeal. Okay, that's what we're going to put. So please go ahead and write that in your Pearson book. We can identify the movement of heat by seeing no more vapor waves in the cup of oatmeal. Okay, very good. And then number 3 here, something very, it says the question. Supposing cold milk is poured into a warm glass, what will happen to the milk's temperature? Okay, who can answer that question to me? Suppose you are adding cold milk into a warm glass. What will happen? I'm going to put all the hands down. So the person that has the answer can answer, please. Let me just put all the hands down. Okay, who knows the answer for number 3? It says, suppose cold milk is poured into a warm glass. What will happen to the milk's temperature? Yes, Amsi?
It's going to be hot too.
Okay, it's going to be hot. Let's see what Lyra has to say. Lyra, what do you need to say? What is it? What do you think it's going to happen to the milk?
Teacher,
Yes.
I don't see the share screen.
Hi, Lyra. Okay. Here. Now? Lyra. Okay. So it says, suppose cold milk is poured into a warm glass. What will happen to the milk temperature? It's going to become hot. Amsi says it's going to become hot. So here we're going to put, it will become hot, comma, because the temperature of the glass is conducted to the milk. Okay, that's what we're going to put. It will become hot because the temperature of the glass is conducted to the milk. Very good. Okay, students, right now it's going to become hot because the temperature of the glass is conducted to the milk. It will become hot because the temperature of the milk, of the glass, it's conducted to the milk. Now, students, so time is almost up. Right now that we come back to the class, we're going to finish reading that page and then we're going to go to the spelling, okay? Right now, time is over. See you right now in 10 minutes, okay? Thank you so much. Bye-bye. See you in 10 minutes. Bye.